Hello folks, we said we were going to solve this type of problem. This is probably a lot more complex than what you're going to get in an examination, but it's worth having a crack at it because it'll certainly test your knowledge and your understanding of resistor circuits. So you need to understand how to add parallel and how to add series resistors to calculate, and how to use Ohm's law to do this problem, and redraw it a little bit as well. So let's just have a quick look and see. First of all, you need to try and simplify these circuits as much as you can. So we can already see one problem that I always have when doing this type of problem is I'll see R2, and that's resistor 2, and I'll write that down as a 2 ohm when I'm simplifying because I'm not thinking straight. Okay, so make sure that you don't put down the value of the resistor as its actual designation like R2, because R2 is not its value is 4 ohm. R2 is a 4 ohm resistor. So anyway, we've got a series situation here and a series situation here. And we know whenever we've got series resistors, we've got an easy situation because we can just add them. Okay, so we can already simplify this circuit to the point where we go, it's 5 volts, it goes into this R1, which is 4 ohms. And then coming down here, we've got R2 and R3. So we've got 4 and 8, so we end up with 4 plus 8 is 12 ohms. And we know once we get in here to this branch here that we're going into parallel territory, so we can't just add any more. So we simplified that series, those two series, and then we go into we'll go across here, and we're going to do, we're going to put our R4, which is a 10 ohm, but I'm going to draw it here just to make my life make a little bit more sense. And then coming from the 10 ohms, we go into another parallel branch. See how it's branching here? That's a parallel branch. So we've got a 5 ohm on one side of the parallel branch, 5 ohms, and on the other side we've got these two resistors, a 2 ohm and a 2 ohm, which we can add. We can simplify again and make it into a 4 ohm situation. So we've already got, and I've already made a mistake here. I nearly made the mistake that I said you shouldn't make, and I said R5 is 5 ohms, but we can see here R5 is 4 ohms. So already I haven't heeded my own words. So this is how quickly you can come undone at this time of night when you're not exactly thinking straight. But anyway, 4 ohms over here as well. So you got 4 ohms and 4 ohms because we put those two together, and they are in parallel, and then they come back to here. So we're getting very close to a solution here. So we need to turn this these two that are in parallel into a single resistor so we can simplify this circuit even more. So we know that R total for those two is 4 times 4 over 4 plus 4. R1 times R2 and R1 plus R2. So we end up with 16 over 8, which is going to give us a value of 2 ohms. Okay, so we know that we've got a 10 ohm and these two become a 2 ohm. So we can redraw this circuit even more simply. We've got 4 ohms, then we go 12 ohms, coming back to the battery, which is 5 volts. And then over here, we had 10 ohms, and we know that that's equal to 2, because we've already done that over here. So 10 plus 2 is 12 ohms. So now, if I was to ask you to solve this circuit here, it's quite simple, isn't it? But you've just got to make sure that you use that process of simplification and you're really thinking rationally while you're drawing the circuit. Sometimes changing the way you draw it helps too, but remember, when you hit a branch, you're going into parallel territory, and then we hit another branch, so we knew we had another parallel. So take your series resistors and simplify them first, and then start simplifying your parallel branches. So we've got a parallel pair here, which would be 12 by 12 over 24, which is 144 over 24. And I should be able to do that in my head, but I'm really dumb. 12 12s is, so it goes in 6 times. So if I'm not mistaken, we can replace this parallel pair with a 6 ohm resistor. So we end up with 4 plus, so the circuit's gone as simple as this. We go 5 volts, we go 4 ohms, we go 6 ohms. It's a parallel circuit. We have 10 ohms in total, 4 plus 6. So now we know that our total resistance, R total for this circuit, believe it or not, resistance total is equal to 10 ohms. And if you want to calculate your current, I equals V over R. And so that's equal to 5 over 10, which equals 0.5 amps, half an amp. So I'm hoping that they don't ever hit you up with a problem like that in the examination. But really, if you're systematic about your approach, you'll be able to solve a problem like that. But at the very least, you need to understand that what's happening with the current in a series circuit. You need to have an understanding of Kirchhoff's current law, understanding that the current splits up and then you get the same current coming out of a branch as you get coming into a branch. And you need to understand the concept of voltage drop. Have a look at all the other videos. Go back over the theory that I've given you, and I'm hoping that you're starting to become confident with this type of question. Anyway, that's it for the Ohm's law. Look for some problems in past papers. Have a crack at them. If you think you're still struggling, let me know. I'm sure I'll be around, and you can just ask me for help or email me for rescue or whatever. Anyway, have a good night.